Okay, let's do another example. Let's say this is a third order system. 100 s plus 1 s squared plus 10s plus 100. Okay, so obviously we can break this into 3 subsystems. Make sure when you break this one, this is a second order systems, but this is not the standard form. The standard form is 1. The standard form, this is coefficient is 1 at this. So make sure you remodify this or divide by hundreds. 1. Now we can break this one. Okay, and actually the coefficient is 1, so we can break 2, k equal to 1, so it's 0 dB, so it doesn't mean. So the other will be 1 over s plus 1, so tau equal to 1, omega c equal to 1 over 1, it's 1 radian per second. This is first order system, 20 dB per decade, and then this one so compare, so you know damping ratio is natural frequency is 10 radian per second. You can get compare, so damping ratio should be 0.5. This is second order system under damp, so obviously you should have minus 40 dB per decade. Also at natural frequency, phase angle is minus 90 degree. At cutoff frequency, for first one, phase angle is minus 45 for this one right here. So these are information we need to construct the second order, this transfer functions, which is the third order systems. So let's do this quickly. So to a Bode plot. So let's make the axis omega, this is 0, this is dB. Okay, from the subsystems, we know first one is 1, so don't need to do this because this is 0 dB, so this one we say this is case 1, this is case 2. Okay, now case 1, you have cutoff frequency at 1. Let's say 1, cutoff frequency 1, so 10, 100, cutoff frequency 1, so this is defined minus 20, minus 40. So first one I can get before that's flat, and from 1 to 10, 20 dB per decade. That's first one. For second one, is natural frequency 10. So 10 to 100, that's 40 dB per decade. So right here. So let me move this one to a further line. Let's use another line from 10 to 100. Drop is 40, exactly right here. So this is the slope, kind of steeper. So this is 2, this is 3. Okay, so what's total? Before 10, the line follow from 0 to flat, 20 dB. Okay, so after that you have minus 20 dB plus another minus 40 dB. So total will be minus 60 dB. So drop 2 more from here. So 20 dB. So you should have a line right here. So the total, let's draw the total line. 0 dB, 20. Okay, from here, 2 is minus 20, 3 is minus 40, so total will be 60. So from the 20, drop 40 more, should be this line right here. So this is the total. Okay, 0, minus 20, minus 40. Okay, so now let's look at the phase angle. Phase angle. Draw the axis quickly. Omega phase angle. So first one you have, let's do that, 45 at 1, cutoff frequency 1, cutoff frequency 1 is 45 minus 45, so 10 times more, 10, that's minus 90, and then flat. 10 times less, that's 0.1, that's 0. So share something like this. Slope, flat. This one should be 0 right here. Okay. Now, for the second order system, the second one, this is 1. Second, that's 10. It's always at 90. 10 times more, that's 180. Right here, minus 180. 10 times s is 0 right here. So the second one you will have this slope. Flat. Flat. Okay, so what will be the total? You add it up. 2, 1 and 2. 1 and 2, you add it up. Okay, so totally you can get to several points. Between this point, this is what? Minus 90, 180, so it would be 270. Okay, here should be this point, minus 90, 190, so 180, this point. So from here, this is the 1, before 1, so follow this line, and then you have this line, this line. So overall, you add them up. You should have the totals. Let's put it in red color. Red color. And then this point. And then this point. And then 270. So this is a total. Okay. So again, you break it into several subsystems, and you know each subsystem's Bode plot. What would be the total? You add them up. Okay.